Assalamualaikum warahmatullahi wabarakatuh. Uh, my name is Khairul Azman bin Jantan, uh, and also my team members is Hazimi bin Azman, and lastly Nur Bazlan bin Samad Sazanuddin. So here we in lab 4, high voltage system. In the section 1, we can see here in this figure, which is have a frequency cabinet connected with the transformer, high voltage transformer, connected with the capacitor, which is the value of capacitor 100 picofarad. And then after connected with the capacitor, in this lab, which is a DC high voltage, connected with the high voltage diode, which is the value of diode 20 milliamp, and connected with the insulating support, connected with the high voltage diode, which is the same value 20 milliamp, and connected with the load capacitor 25 nanofarad, and also measuring resistor, and lastly which is a ground switch. So in this figure we see have several safety purpose, which is have using a braided copper wire in the earthing system, and also using a coaxial cable, and also for safety purpose. And then we go to the safety rule that we need to concern at the earthing switch before testing a DC high voltage measurement. So we have to double checking the connection and ensure it's connected properly. As we know, in this lab have the earthing should be below than 5 ohm. So for the safety, we can also try to pull cable to ensure it's not loose. Since the top of electrode make it possible to raise primarily discharge voltage to very high value, so the earthing switch must have connected to the top electrode properly. So the distance between top electrode and earthing switch must be accurate. And lastly is a safety precaution. Preference must be given to operating, energizing, re-energize equipment from a distance or via remote means. When a return from a break, the switching operator must be confirmed with the controller that they are still working from the correct schedule version and are the right step. So thank you for the section 1.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Bazlan bin Muhammad Sazanuddin. My matric number is D0717107556. And for the lastly, for our lab 4, I will be present about our section B, which is for the part 2. So, firstly is about our source control, which is on the left side of this figure. Figure shown the main command window for the source control, and for our source control that will be have 3 step, 3 of the manual step, which is can be labeled as the constable, corporal, and the sergeant. For the constable level, the gain value is set up at the 0.1, and for the corporal level, the gain value will be set up at 1, and the lastly, for the highest level in our manual step is the sergeant level, which is that will be gain value will be set up at 10. And then we have the primary side of the transform progress, which is this primary side of the transformer progress is will be at as our references when the injection process is running. So in this primary side graph will be contain the value of the voltage and the current during our injection progress lah. Okay, and then we have the system monitoring of the secondary side, which is in this laboratory testing we will be use two section of the frequency converter injection, which is for the AC measurement, and also will be use the DC measurement, which are the for the AC measurement will be connected the coaxial cable from the secondary unit to the frequency converter at the VM1, and for the DC measurement, which is the coaxial cable will be connected from our secondary resistor unit and to the VM3 of the frequency converter. So and the other slot, which is for the third and the fourth slot, are required for the VM2, and this VM2 also will be indicate for the AC measurement only, and the other slot, which is the 6th slot, 7th slot, and the 8th slot are required for the VM4, VM5 and VM6 connection respectively. Okay, next is our alarm system. Basically, for the alarm system, for this experiment, for this laboratory testing, same with the previous laboratory testing, which is we need to make sure all the alarm in a good condition, which is for the first figure, the condition of the alarm that will be triggered is in the closed circuit, such as all the door must be closed properly and the emergency button is in the release position. And the second condition, which is in the middle figure, which is indicate that the door is open or the emergency button is pressed. So at the command window, the pop-up message will be appear in the window. And for the third condition of the alarm system can be shown in the last figure, at the bottom figure, which is we must be make sure all the door must be closed properly and the emergency button must be released. So in order to set the alarm in the good condition, which is we must press the red alarm button and press the reset button at our command window. After that, the alarm button will change to the green alarm button, which is it will be indicate the system is ready for the injection process lah. Okay, next is our serial number and the voltage divider ratio, which is for the serial number, which is in our laboratory, this laboratory testing have two secondary unit that will be used, which is the secondary resistor unit, which is in this secondary resistor unit have their own serial number, not same with the previous laboratory, because previous laboratory we use the secondary capacitor unit. So for this lab we'll be use the secondary resistor unit, which is the voltage divider ratio slightly will be different with the previous laboratory testing. So for this testing, will be use the secondary resistor unit, which is contain the voltage divider ratio about 20414.4 volt divider ratio. So the function of this divider ratio, this voltage divider is to be set up in the system setup default in order to make sure all the testing process can be worked properly by using the correct equipment with their ratio of the measurement. And the lastly is the most important section of the picoscope of the most important section of the picoscope window. So for the previous laboratory, which is there are a lot of component that I already explained to you, which is basically those setting will be same in this laboratory testing, but for this laboratory testing we have two more setting that we need to catch up and must be setting properly in order for the injection process can be done properly, which is for the first picture, which is for left picture and the right picture. For the left picture, left figure is shown for our the DC measurement, which is for the channel B, while the right figure indicate for the AC measurement for the channel A. So firstly we must make sure for the channel B, make sure the coupling must be set to DC coupling, while for the channel A must be set to AC coupling. This is because it will be related to the connection of the coaxial cable that will be we already connected to our the frequency converter, and then we must also make sure that the voltage divider ratio of the secondary resistor unit, which is 20414.4, must be set up in the channel B, while the divider voltage divider ratio must for the channel A, which is for the AC measurement, must be set same with the previous laboratory testing, which is 19651.1. So and then the lastly we must set for the Bose setting, which is for the outer range. We must set all the setting to the outer range in order to see the changes of the one range to another range. So that's all from me from the section B. That's all from me. Thank you.
Okay, so this section 3, the comparison for analyzing the reference signal and display signal. Okay, so this table for the comparison between reference voltage and display with the variant output voltage 0%, 10%, 20%, 50%, 40%, and the maximum is 50%. So this is the table, the raw data that we get on this lab. Okay, so this is the graph for the table below. The difference between different voltage and the display is quite similar. Okay, so since this lab measure the DC output voltage, it require a divider ratio 2041.4 and the rated voltage is 140 kilovolt. On this lab, it use VM3, which means we need to be on slot 5 to simulate the data, and we need to set up by set the coupling on the DC condition, and the range of scope is very important to see the ripple when the output voltage is increased. So as you know, for AC and DC in principle, we present for two slots, which are slot 1 and slot 2 for VM1, slot 3 and slot 4 for VM2. So when we need to measure the DC voltage, it use a third termination or the VM3 that represent the slot 5. Okay, so the results show the highest value error is 13.33%, which is for the output voltage 0%. Then the minimum value of error in this lab is negative 6.142, which is for the output voltage 20%. Okay, so lastly, when the voltage is reduced to 0%, it shows some sound that the discharge sound from the testing room. It is because the charging capacitor can hold high energy, thus the current will flow to the grounding and it will create a spark between fading switching rod and top electrode. Thank you.